Alrighty, so welcome back. Hope everybody had a nice Thanksgiving, nice little break. So we're going to look at the week 7 material, and that is on multiplying polynomials. So there's different ways that you can do it. I'm going to teach you kind of a strategy that uses a box. And what the box does, it just organizes the steps. So if you have trouble kind of remembering, what to do, how to do it, the box is just kind of an organizational way to help you. All right, so the kind of thing, let me just show you an example of what we're going to look at. That's the kind of problem we're going to do. So some people, when they learn how to do that, they call it like the double distributive property, because you get to do distributive property twice. Some people also learn a word called FOIL. Has anybody learned that before? FOIL, yeah. It's just an abbreviation for the order that you do it in. And then some people learn to draw like this box kind of chart. That's you. And that can also help you. So the idea is if you already have a way that you know and it works well for you to do what we're about to do, I would stick with the method that you use and that works for you. If you have trouble, this might help you. All right. So when we use the box method, let me kind of put one up at the same time. You're going to have two sets of parentheses that you need to multiply together. In this particular one, there's going to be 4 terms. The 6r is a term, the 2, the 7r, and the 3. You take the terms from the first 2 sets of parentheses, the 6r and the 2, and those are going to go across the top of the box. I usually write them on the outside of the box. I guess you could put them at the very top because I don't have much space there. Don't worry, we're going to do that one second. But you take the first 2 terms, you write them across the top, and then you take the second 2 terms and you write them going down. That's what those first 2 steps mean. Right, so you put 2 of them across the top and you put 2 of them going down. It doesn't really matter which ones you put where. All right. If you put the 6r and the 2 going down instead of across, you're still going to get the same answer. All right, but you put 2 across and then put 2 going down. Okay, so when we multiply, let me show you an example of how that works. Okay, sometimes people get mixed up with, what do I do with the exponents, and then what do I do with the big numbers that are in front? So here's kind of a simpler one. So this one doesn't have 2 things inside the parentheses. It only has 1 thing inside. So when you multiply these together, it says multiply the big numbers. Okay? So the big numbers are the numbers in front of the x's. So if I start with that, what is 3 times 2 give me? 3 times 3 on the right? 6. Okay, so we multiply the big numbers. And now it says to add the exponents. Well, there's no exponents on these x's. Does anybody remember what number is always on a letter if you don't see anything written there? There's always a number there, even if there isn't one written. Yeah, right, it's a 1. So if you don't see a number and you want to put the number in, you can put it in. So it says multiply the big numbers, we did that. Now it says to add the exponents. Okay. When you multiply these together, you're still going to have an x, but it's going to have a new exponent. The exponent that you put right there is going to be what you get when you add that one to that one. So if we add 1 and 1, we get 2. So the answer to that is 6x squared. Right, let's try another one. 4x times 3x squared. So let me start with the big numbers down. If I multiply the 2 big numbers together, what would I get there? Yep, so 4 times 3 gives me 12. We started with some x's, so we know we're going to have something with an x, but the exponent is going to be a new number. It's going to be the number that we get when we add the exponents here. All right. So Isaac, since I don't have a number on this x, what number can we put there? what number could we put on that x?
1.
Yeah, you can put a 1. And then if we add the exponents together, we have a 1 and a 2. That gives me a 3. So when you multiply 4x times 3x squared, you get 12x cubed. Yep. Any question on that idea? It's kind of a simpler version of what we're going to do today. We're going to have a few more terms in it, but those are the basic operations. Okay. Now, this box method, it can work for any type of problem. You just need to draw as many rows and columns in the boxes as you have terms. So that's an example where you have 2 and 2. So you make 2 rows, 2 columns. Here's an example where you have 2 and 3. So you make 2 rows, 3 columns. Right? If you had an example that had 3 and 3, you would make one with 3 rows and 3 columns. So basically each box that you make is a step in the problem. So this particular problem is going to have 6 steps. The one above it, 4, and the one above that is also going to have 4. All right, so now the very last part, it says right here, combine like terms. When we are combining like terms, let me show you how that would work. Let's take the answer we got from the first part, 6x squared, and let's add that to 4x squared. Okay, combining like terms is a little bit different than multiplying these together. Okay, combining like terms is more like adding. When you combine like terms, this never changes. Okay, so if you started with an x squared, you're going to end up with some x squareds in the final answer. It's just a matter of how many of them. Well, if you have 6x squareds and you add 4 more of them, how many x squares would that give me altogether? About Eli.
Can you say that again?
If we add those together, what would we get?
4x?
Well, we have a 4x squared and we're adding a 6x squared to it.
So 10x to the fourth, to the second?
To the second, right? We already had the second, so we're going to keep the variable with the exponent the same, and we just add the numbers in the front. Okay, so that's what happens when you combine like terms. This number does not change. It only changes when you multiply. Okay. Let's try another one. Let's try like 8x cubed plus 4x cubed. Okay, when I'm done, because I'm adding, I'm still going to have x cubes. It's just a matter of how many. So Ben, if I add 8x cubed and 4x cubed, what does that give me?
12x cubed.
12x cubed. Yep. All right, same thing for subtraction. If you had like, let's say, 5x minus 3x. When you're done with that, you're still going to have just x's. Okay? And there's no exponent on any of those x's. So what is the exponent, even though we didn't write it? It's all to the first. So you're still going to end up with an x to the first. And 5x minus 3x would leave me with how many x's? Yeah, 2. So it leaves me with 2 x's. Okay, how about this one? 8x squared plus 7x. Have an idea what's going to happen there. What's that? Oh, yeah, you just said it. Anyone think they know what's going to happen there? Okay, well, first of all, what's the exponent on the first x? Madeline.
The first x 2.
Yeah, the exponent on the first x is a 2. What's the exponent on the second x? Yeah, it's a 1. If they're different, they can't be added together. So when you're trying to add those up, you can't. Right? They can be different when you are multiplying them. That's fine. But when you're trying to add them, that's a fine. There's nothing you can do with that. That would stay exactly the same. Okay? In order to add or subtract, you need to have what are called like terms. Like terms have the same letters, and each letter has to have the same exponent. Okay? So the first three were okay, but the last one, no. All right, now let's do one more, and then we'll do the ones on the worksheet. This is perfectly fine. That's a totally different problem than the one above it. The top one is adding. What operation am I doing in the bottom one?
Multiplication.
I'm doing multiplication. That's totally different. That you can do. And that's where you follow these steps. Multiply the big numbers in front, and then add the exponents. Okay. What do I get if I multiply 8 times 7?
56.
Yep, so it's going to be 56. And I know I'm going to have a certain amount of x's, but the exponent is going to be what you get when you add that one to that one. So that's a 2, that's a 1, and you get 56x cubed. Okay, so that's a good one that really shows the difference between the two. That's combining like terms. The bottom one is multiplying. All right, and now we're going to put all that together and try some from the worksheet. Okay, so the first one we're going to look at, it's only going to have two steps. We've got one term, and we've got two terms, 1 and 2. That means when you set up your box, you need one row, 2 columns. We're going to start by put the 6v on that row, and then the 7v and the 6, those are going to go across the top. And what's going to go in each box is what you get when you multiply together. So in this first box, I'll just write down what we need to do. It's 6v times 7v. We need to do that out. And then in the second box, it's 6v times 6. All right, let's do that first one. Okay, so first one, start by multiplying the big numbers together. Derek, what do I get when I multiply 6 times 7?
48 squared.
How much is 6 times 7?
48.
That's 6 times 8. 6 times 8 is 48. 42, yep. So 42. And we know it's going to have a v in it. And what did you say the exponent would be?
Squared.
Yep, perfect. It would be a 2. Because that's a 1 and that's a 1. And when you multiply, you take those two 1s and you add them together to get a 2. Perfect. All right, the second one, 6v times v. I'm sorry, yeah, 6v times 6. Now, if you look at that one, you're like, well, wait a minute, the second one doesn't have a v, that's fine. We're not adding them, we're multiplying. So we can do that fine. So let's start with the big numbers in front. 6 times 6 gives me how much? Yeah,
36.
36, perfect. And we know we're going to have a v next to it. What's going to be the exponent on the v when I add up the exponent on the v in the first term and the exponent on the v in the second term? What's the exponent going to be? Oh, Gigi?
Just v.
Yeah, it's just v, because this is v to the first. The 6 doesn't have a v, so it doesn't contribute anything else to the problem. So it just stays 36v. Okay, so that's the multiply step. And now the last step is combine like terms. So take everything that you see in the boxes and now add them together, if you can. So copy down every box and just put a plus sign between them all. Okay. Now we want to try to add those two together. Can those two be added together? Select?
No.
No, they can't because this is a v to the second, that's a v to the first. So when you're adding, they have to be the same, and they're not. And that's it. That's how you multiply those together. Okay, so that's multiplying a single term and a two-term. Okay, now we're going to try a two-term and a two-term. But first, any question on that? Okay, let's try this one. Okay, so second one. It's set up to have 2 rows and 2 columns. So what I would do is let's take 6r and the 2. Okay, and if you put them across the top, you're not wrong. You can do it that way. That's exactly the same thing. So I'm going to put the 6r and the 2 going down. Can anybody tell me what's going to be the 2 that go across the top?
7R plus 3.
7r and the positive 3. 7r. I would normally write it outside the box. I don't have any space above it on my notes. Okay, so let's write down what we need to do in each box. So you don't have to give me the final answer. Just tell me what I'm going to do. What am I going to multiply together in the first box?
6R times 7R.
Yep, I'm going to do 6r times 7r. So we get ready to do that one. What am I going to multiply in the upper right box? 6r and 3r. Yep. Okay, so we got to do that one out. Okay, what am I going to multiply in the bottom left box?
7R times 2.
I'm going to do the 7r times 2. If you think of it as 2 times 7r, it's the same thing. Just multiplying them together. And what am I going to multiply in the bottom right box?
2 times 2.
2 times 3. So in green is the step I need to do in each box. All right, so now let's start in the upper left. 6r times 7r. Emily, when I do 6 times 7, what does that give me? 42, perfect. And we know it's going to have an r, but we got to add the exponents up on the r's we have. So it's going to be 42r to the what power? Second. Yep, it's going to be 42 r to the second. Perfect. Okay, the one in the upper right, 6r times 3. Okay. Multiply the big numbers together. What's 6 times 3 giving?
6 times 3, 18R.
Yep, 18. And this one is just an r to the first because there's no other r to add an exponent with it. Perfect. Okay, lower left, 7r times 2. It's 14r, because there's no r to combine with that first one. And the last box, 2 times 3, gives me 6. Now, take all those things we just wrote in black and just put a plus sign between them. So 42r squared plus 18r. Now, if one of them was a negative, like if this was a negative 2 times 3, that would be a negative 6. Okay, so you can get negatives. 18r, 14r, and 6. Okay, so I wrote down all 4 answers from each box. Are there any there that I can combine together? We're looking for anything there that would be like terms. Yep, you can combine 18r and 14r. Okay, those are the only like terms. The 42r squared, you can't combine that with anything else unless you see something else with an r to the second, and there isn't. The 6, you can't combine that with anything either. So all we have to do is figure out what's going to go in the middle. Well, we're combining something with r's, so when we're done, we're going to have an r. It's just how many. We have 18 r's, and we're adding 14 more. How many r's would that give me?
32.
Yep, 32. And that's your answer. None of that can be combined together because there's no more like terms. That's the final answer. Okay. Any question on that? Okay, let's try one that looks a little different, but it's actually the same thing. Okay, it looks different because it's 4m minus 7 to the second power. Well, if we write that out like the one above, what does 4m minus 7 to the second power really mean? Like if you had to write that in a way so you didn't have that. Like how would you explain what that means if somebody doesn't understand a number that's up a little bit higher? What does that number mean to do? How about Samantha? What does that number mean to do?
That it has to be doubled.
Right. So what would go in this first parenthesis if you write this one without that little 2?
4m minus 7.
So you'd have a 4m minus 7. And what would you put in the second one?
4m minus 7.
Yeah, it just means to write the same thing twice. Yeah, perfect. And now we can do it just like the top one. So now put 4m minus 7 going down. And because it's a minus, we are going to get some negatives this time. So I got 4m minus 7 going down, and then what's going to go across the top?
4m minus 7.
Yeah, you're going to put 4m minus 7 again. Perfect. All right, and now I'm just going to write down what we need to do in each box. So the first one is 4m times 4m. How about, Ryan, what's going to go in the upper right box?
Negative 28
Yeah, can you tell me what you do to get that?
4m times negative 7.
Yep, 4m times negative 7, and what you said is perfect. I'm just going to write that in the next step. Okay, Brady, how about the lower left box? What are the two things we're going to multiply there?
Negative 7.
Did I say lower right? If I did, yeah, that's right. How about the lower left?
Negative 4, negative 7.
Negative, say that one more time.
Oh, I'm in 4m, negative 7.
4m and negative 7. So 4m and negative 7. Okay. So let's do those out. Let me fix my negative because that doesn't look too good on that one. Looks better. Okay. Let's start with 4m times 4m. How about Acadia? What's 4m times 4m?
16
Perfect. 4 times 4 gives you 16. And you have an m to the first and an m to the first. Gives you m to the second. Okay, I think Ryan already said the one in the upper right, negative 28m. And because I'm multiplying the same thing together twice, I'm going to see that answer again. Where else do I have a negative 28m? The bottom left. Yep. Okay, and let me just fix that one so it looks more like a negative 7. All right, and then in the lower right, what's negative 7 times negative 7? Well, negative times negative, yep. It's going to be a positive 49. Okay. So now take each one of those answers in the box and write them down, combining them all together. If it's a negative, leave it as a negative. So 16m squared minus 28m minus another 28m plus 49. All right. There are two terms there that we can combine together. Anybody tell me which two we can combine? Yep. And which other one?
Negative 28m.
Yeah, those can be combined together. So the 16m squared, nothing you can do with that. The plus 49. Okay, nothing you can do with that. We have negative 28, and then we need to minus 28. Right, so if you get stuck on that one, we can use our calculator. But does anyone know what that's going to come out to?
Negative 56.
Yep, negative 56. And because we're combining like terms, we keep the letter exactly the same. Well, actually, keep the exponent in the letter exactly the same. Okay, any question on that one? All right, let's try the last one. So this one has 2, and then it has 3. What are going to be the ones that I write going down?
We're supposed to.
Yep, I'm going to do a 4x and a positive 7. And then what are going to be the ones that go across the top? Gigi?
The 8x squared
Yep.
and the negative 2x and the negative 8.
The negative 2x and the negative 8. Yep. Okay, so this one has 6 multiplications we need to do. All right, let's start with the first one. I'm not going to write down in green this time what I need to do. I'll still say it though. Right, it's 4x times 8x squared. Anyone think they know what that's going to be when you do that whole thing out? Yeah, Ben?
32x cubed.
Perfect. 4 times 8 gives you 32. And because you're multiplying, you need to add the exponents. That's a 1, and the other one is a 2. So that gives me a 32x cubed. Nice. Okay, let's go right across the top. How about the middle box in the top? 4x times negative 2x. Anyone think they got that one? How about Darwin? Did you get that one?
Negative 8x. 2.
Say it again.
Negative 8x squared.
Yeah, perfect. Negative 8x squared. Yep. 4 times negative 2 is negative 8. That's a 1. That's a 1. Add them up, you get a 2. Okay, and the last box. 4x times negative 8. Eli, what would you get for that one?
Or 4x minus negative 8.
4x times negative 8.
Negative 16. 8.
So start by multiplying the big numbers. What's 4 times negative 8?
That'd be negative 32.
Negative 32. And then what's going to be the variable that's next to it?
X.
Yeah. It's just going to be an x because we don't have anything. We don't have anything to combine it with. Okay, so negative 32x. Now let's do the bottom. So 7 times 8x squared. Well, Ellie, what's 7 times 8x squared? Yep, so the number is 56. And what's going to go next to it? Yeah, we don't have any x's here. We only have 2 of them there. So x squared. Yep. How about the next one? 7 times negative 2x.
Negative 14x.
That's negative 14x. And the last one is 7 times negative 8. Well, we've already multiplied 7 and 8 before, so we know it's a 56, but this one's a negative 56. Okay, so now looking at those boxes, I'm just putting numbers so we can easily talk about them. Does anybody see 2 boxes that have like terms that can be combined? Box, yeah?
Box 2.
Yes. Box 1 can't be combined with anything. So let's write that down. Box 2 and box 4 can be, because they're both x to the second. 56, take away 8. What's 56? Take away 8. 48. So positive 48, and we combine things that were x to the second, so it stays x to the second. So we got that one, and that one. Does anybody see two other boxes that are like terms? Yeah.
3 and 5.
3 and 5. Yeah. 3 and 5. Negative 32 combined with a negative 14. That's going to give you an even bigger negative number. What's negative 32 and negative 14 give you?
Negative 46.
Yep, it's a negative 46. And because we were combining x's, we end up with just an x. And the last one is negative 56. And there's nothing you can combine with that. Okay. So the last thing I'm just going to take a look at for probably like 1 minute is the MCAS. So the MCAS, or not the MCAS, the worksheet this week is all about finding the area of these different rooms. Well, when you find area, you multiply length times width. So you're going to end up multiplying two things together just like we did before. The only thing you don't know is some of these other measurements, but we can figure them out based on the diagram. Okay. They tell you up above that the kitchen and the bathroom are squares. Okay. That's important. So you have to read that to know that the kitchen and bathroom are squares. Okay. Look at the living room. Okay. It says the width of the living room is 3x minus 2. Does anybody see what other room in that picture would also have to be 3x minus 2 because it's in line with it? The bathroom. So they don't label this as 3x minus 2, but it has to be because it's connected to the living room, and the living room and the bathroom are lined up. Now it says the bathroom is a square. So what does that mean the bottom side of the bathroom is?
3x minus 2.
It has to be the same as the other one. Right? And because the living room is 8x plus 5, I'll just give you a hint, something else is 8x plus 5 in that picture, and you can go from there. So that's the idea of the worksheet for this week. You've got to figure out a few of the other sides you don't know, but they line up with something else in the picture, so you can figure it out. And that's the guided notes for this week.